I'm going to really talk about, and I've used the words very carefully, and you'll notice I've used the words our, because basically these people we're creating are going to create the buildings of the future. We've managed to get this great thing, the internet, up and running, but it has lots of problems and so on. And really our future will be built within the internet. So the days of buildings being created, of institutions, really the buildings of the future will be created within inside the internet. So really what we've got to try and do is really to stimulate those people into this area and also make them think about the possibilities that are actually there. So I'd like to present a few different things around this. Look at the state of the industry in Scotland just now, and really we need to articulate that to kids. We have a massive problem in that we just can't produce enough graduates. We could easily double or treble, and we probably still wouldn't be able to cope with the demand. So there are a few careers out there that gives the scope of opportunities and gives salaries that are possible, and all to be able to live in Scotland without having to go elsewhere. So I'll have a look at the state of the industry. We deal a lot with industry, and the one thing the industry asks us is give us some graduates, get more kids into computing. Really, we really want well-rounded individuals who aren't specialists but can understand a whole range of things. So myself and Adrian have been working on a research project looking at the M5 curriculum, and it's really quite exciting. Exciting is one word for it, and launching is the other one. I know how difficult it must be when you're looking at this M5, but they've done it in a winner, and they've went ahead with it. It's going to happen. There's little we can do, but actually computing it. Because 10 years ago, things in computing, we talked about modems, even 5 years ago, the concept of IP addresses probably wasn't there. So computing has changed so much. When I started in computing, it was mainframe computers, and now we have the clouds and so on. So it's a good opportunity for us to refresh our subject, to look again at what should be covered, and really to touch base with what's out there and what's relevant for kids. And hopefully it's interesting. So we'll show you some of the research work that we've been doing with the publisher and some of the ways that we've tried to simulate things. We'll ask you a few questions about what you perceive as a university course, what you think motivates kids, and a few other things like what's your passwords. So what's this? So and then we look at our cyber stuff. We thought we promoted a cyber lecture in Scotland. We thought we'd get 12 kids or so, and we got 800, and they were being bussed in from Inverness and so on, which worried us because it was in December. It wasn't really a very good time to be bussing kids around. So I'll outline that. This year we've got something, it's only 3,000 kids or something like that, which is quite scary. So that was our way of putting something back, trying to get more kids. Seems that possibly universities in Scotland haven't tried hard enough to be able to attract kids into computing and so on. We are capped, so unfortunately we can't increase our numbers and so on. But we'll show you where kids are likely to fit into the future. We have lots of different ways. Someone can go out of education for a while, go to college, and come back in. And I think the model is likely to be around a school, college, university type model, maybe dipping in and out, coming back, but always having the opportunity to achieve the maximum potential. Okay, so those are some of the things, and we'll just take a walk through that. So what's the state of the industry just now? Well, it's unbelievable. I've never known in all my time as an academic, I have never known, even the good times, the 80s and so on, I appreciate there weren't good times for many, but the good times when the economy was buoyant, there has never been such a demand for IT graduates. You see Skyscanner, After over 200 jobs, we see CGI just down the road here, 250. Dell SecureWorks, SAS, after 200. In fact, SAS have moved to Glasgow, so they can be very close to the graduate community. There's never been a time like this. When I first started as an academic, my graduates typically went to London and down south and so on. These days, they can quite have it. In fact, to go from one end of Prince Street to the other is a major thing. It's an Edinburgh thing. I'm not going to the east side of Prince Street. That's a long way to go. I want to go to the west side. Because you actually find that companies are now basing themselves right in the centre of cities because they know the graduates probably won't want to travel and so on. So it's a good time, and really it's a good time because the whole industry has moved up one level, or lots of different levels. So you find a lot of jobs are talking about architects. So our graduates are going to become architects, and they are because they're building, they're designing, they're looking forward, they're really creating the infrastructures for us all to live and work in. So few jobs could offer the opportunity to become an architect, to be a designer, to be an analyzer, to be a tester, and to build something. You can find a job in any of those areas if you're more a tester than an architect, you're more a builder, putting it together, then there's a career for you. So you can see there are lots of different options, and this has really changed over the last few years that we've seen this moving up from a technician type level to engineer level. And the good thing is there's so many different jobs. There's networking, security. We just can't produce enough security people. Forever companies are on the phone to us saying, could we have more of your graduates? Could we come and speak to them early on? Could they come for internships and so on? Software development has gone through the roof just now. There is a massive demand for software development. There is an almost endless demand just now. There are many posts that are unfilled in the industry. And then, if you're more creative, I appreciate software development is creative too, in a certain way, but if you're more creative, there's a lot of jobs around for user experience, user interaction, web interfaces. Software isn't any good if it doesn't actually have a good interface on it. So there's lots of opportunities around designing for mobile applications and so on. Mobile devices has also happened, and there's a large scope for development. When we designed our new N5 site, straight from the very first off, we knew that mobile devices would be supported. We knew iPads would be a key thing, but also knew that the teachers would be using large screens in the class, possibly touch screens. So we had to design with all that scope, and hopefully we managed to do it. It might not be perfect, but we know that mobile devices is a very good thing. Typically, it's pupils watching a lecture on a bus, doing a test just before the exam, doing a catch-up, and so on. And then web development is obviously picking up. And then every single year, there's a new area that comes along, computing. Cloud, people said cloud, it's not going to work, that's not going to happen, it's just a fad and stuff like that. Cloud is de facto. Cloud businesses move to the cloud, businesses run their software in the cloud, people put data in the cloud, and so on. And then we have big data. So more and more organizations are using data from lots of different sources and so on to be able to understand how they can improve healthcare and so on. And then obviously mobile devices. So we're very lucky. Anyone who picks a career in this area is really going to be the rock star of the future. The kids that go in now have the opportunity. I seen a tweet. It was first day at school for this little girl. She says, "I told my class that my daddy was a hacker." How good is that? So that's the state that the industry is now. And the other good thing is it's really part of all our lives now. You can't disconnect the internet. You can't take it away. It's really an important part of virtually everything that we actually do. So 12 terabytes of tweets every single day. 90% we're just at the starting point of really moving our whole lives, everything into the cloud. 90% of all the data that's in the cloud is just produced in the last 2 years. And when you think of that increase up, you can really see how it's changing our lives. 2.5 quintillion bytes, that's a billion hard disks of data is produced every single day. So if you're a police officer and you've got to analyse that number of disks, it's going to take you an awful long time. So things like detection of crime and so on are changing because people are moving to the cloud and so on. And everything, all our industries, are now moving towards some sort of IT, banking, oil and gas, e-commerce, transport. Couldn't really exist without any sort of IT infrastructure. So you're not going to turn off the servers. In fact, if you do, then you could cause serious problems. An outage in the oil and gas, I appreciate what happened recently in Greensmouth, and it nearly did happen, but an outage in oil and gas on any of the systems could cause major problems for the whole country and for the economy. And basically the system that created the internet was meant to just be a few little computers connected to this funny little thing called the internet, with a capital I. And they said, well, we'll give it an IP address, 32 bits is enough. Who's ever going to need the amount of addresses it would ever need? But we ran out of IP addresses a few years ago. There isn't enough to go around. That shows how much it's actually used. So more and more data, voice, video, sensors are all being moved to the internet. And in Scotland, we have a whole lot of big companies. We have core industries, and we have the up-and-coming, I say rock stars there because Rockstar is there, the up-and-coming SMEs that are standing up on an international world level and pushing forward because they want to make Scotland their base, because they want to get access to graduates. I mean, that's the time that industry would be located by a river so that it could get water has kind of gone. Now it's the workforce, it's the graduates, it's the skilled workforce that you want. You want to be able to attract graduates and you want to keep them. So it's enough to give them a job, but do they want to stay and live? And Scotland is an excellent place to live. It has fine cities, it has great countryside just within walking distance and so on. So we see big tech companies, a Morse Group, our Glasgow-based company, moved from SME to large company. They do a lot of the security around large airports, doing very, very well. They're just taken over by Lockheed. Hopefully that will take them on one step further in their career. Eventually, big companies become even bigger companies. And we have SAS moved to Glasgow from Cisco Academy, desperate for graduates, for software developers especially, so keen to engage with universities and schools. We have Sopra, Cisco, Amazon is based on Princess Street there. A company of DelSecureWorks is based in Princess Street, actually. Halfway along Princess Street you'll actually find DelSecureWorks. They have a special operations centre for the whole of the world. They're actually based in Princess Street. And then we've got the finance industry and so on, key consumers of computing IT. Without IT, banks really couldn't exist in their current form. And then you've got all these little companies that are really making a mark on the world stage. ECS, there, Rockstar, Flexiant, and Skyscanner really show how it's possible to create a world leader within Scotland, based on Scottish intellect, Scottish graduates, and so on. So this is really a good time within the industry, and really it's the whole of the infrastructure is really dependent on that. So what do we have in this? So there's a major change, and it's a big bang in that we're moving away from old syllabuses towards new ones that are much more relevant. So N5 gives us a chance to really look at the syllabus, to reflect and to change. And the one thing that has been criticised about the previous syllabus is that it was too old, out of the box, it wasn't relevant to what industry really wanted, and it didn't stimulate the kids at all. So certainly with my sons, I told them, don't ask me anything to do with the syllabus at all, because I'll give you the wrong answer. A question might say, what's a modem? I said, well, I could do a whole thesis on what a modem actually was. What do you want? Tell me what you're looking for. Another criticism really was that there wasn't enough software in there. So like it or not, graduates will do software. They might be doing the scripting to make a network device work better. It's a Python script. Or they might be a core software developer or so on. Software, or it's a database, an Excel, it's an Access database or an Excel spreadsheet. Software is a core part of what most people do. And it's key, it's important to get those skills. So hopefully, the revised syllabus. So we've been working with Bright Red Publishing on the range of books. And the good thing is that there is much more focus around software. So if you actually look at the coverage of it, much of it is focusing on software development and so on. So I'd say about half, certainly the software development unit there is the one that's really focusing on software. So you need to get kids to understand that software is a key part. They might not be a core software developer when they finish, but there's a very good chance that they'll be using software in some sort of way. And I'll show you our syllabus to actually show you where software actually fits in. So the units are really split between software development and systems design. Systems design is much more looking at architecture, networking, security, ethical issues and so on, but the other part is really focusing on software. And it's a key task to get kids to be much more interested in that. So in terms of CPD that teachers might want to do, it really kind of splits into two. The second part, the systems design part, is really focusing on things like networking. It's slightly unfortunate that networking covers one unit there. Well, a lot of our graduates are working in networking. Hopefully, the higher equivalent of the higher syllabus will do networking. So a lot of our graduates go into networking, because networking is a key thing. But there's the Cisco CCNA, which is an excellent certification to take for kids and for teachers and for everyone. It gives you a good grounding in how to set up networks, IP addressing and so on. There's Certified Ethical Hacker certification, which gives you a good broad knowledge of security, goes into things like cryptography and so on. And if you actually look at the syllabus now, luckily there is quite a bit around security. So it's certainly going to be an area that is going to be covered more, and the industry is demanding more and more security. You can see many of the risks that actually happen. Many companies are recruiting heavily in this sort of area. And then there's things like VMware certification, how to set up a cloud, how to set up virtual environments. All our labs are virtualized in the cloud now. Someone at home can log into our lab. In fact, some of the labs that we run, you're not allowed to run on the internet. We use tools and so on that really you shouldn't be running in an open space. So we run it within a private cloud. So VMware certification is certainly a good area to look at as part of possible CPD. And then in terms of software development, really most software is now splitting into C#, .NET, or Java type training. It's kind of 50-50 in the market just now. You go for Windows or you go for Linux. That's normally the choice that they do. You actually find the finance industry in Scotland is recruiting very heavily in software development because they have a lot of legacy systems, old systems that kind of work, but let's actually stop using it like that. Eventually we need to redesign it. So they're actually recruiting heavily, which offsets a lot of the industry because they can pay high, so there's a lot of movement around software development. And then there's things like ASP.NET MVC and database database is the number one subject. The number one technology is SQL. So SQL databases and so on. It's the core part of many big companies, and data is becoming more and more important. So SQL, although it's not quite covered as SQL, databases not quite no. Databases, SQL and so on are key. You find most businesses are using it now and will increasingly use it. So that's really what we think. We've developed a whole website and web material for all this. So as I said, a key focus for us was really to make sure that it's fairly well covered in terms of the web material. So we know that kids will use the internet and the web more and more. What we don't want is kids to stop reading and kids to stop looking at books and understanding the material and so on. And what the web should provide is some additional resource that you don't actually get. And it's really the resource when the teacher isn't there, how do we support the pupils actually better? So if you have time, we've just released the new computing syllabus. We'll be looking for feedback greatly. We have tests and so on. Certainly in mathematics we have lots of different calculators and things like that. But really it's trying to make the learning environment much more engaging and interesting. Okay, so in terms of CPD, really that's the possibilities. We run a Cisco Academy, a regional one, and then many colleges run a local academy. So you'll always find someone who does that certification. So just to see if the system's actually working, could you just see where you're from? Is that working? Good. That's excellent. Right then, so I think good. Okay. So half of us are from Glasgow and Edinburgh. None of us are from the borders or the Highlands, so we can talk about them now, it's okay. And I'm good from England, that's a long way to come up, so N5 doesn't apply to you wherever you are. Okay, so that's how. How long do you think for our honours degree in Scotland does it take? From school, entry, to go straight from school, how long do you think it takes? And that is correct. It's 4 years honours. 4.5 years if you do an internship. We always like our students to do 1 year internship because they know what they're doing in the final years. They've got jobs that are well set up. So it could take 4.5, but 4 years is the normal honours year. So if you look at where we start at 7, so this is 5. 6 is that one level up, and then we start at 7. And then we go all the way up, we go up to PhD, which I think is 13, but I'm only showing the top part there. So we start first year, and this is a security course. This is our computer security and digital forensics course. And you actually look at first year. It's got HCI, it's got information systems, it's got networking, and it's got software development. And really, this is us saying, have a look at all the career options. What is it you really like? They're maybe not mature enough. They might be 17, they don't really know. Their uncle does some software thing, they don't quite know what the career is they really want. So you can see there, the first 2 years are allowing them a way to articulate between the courses. So don't tell kids that once they're on a degree in computing, they're going to stay there because they can really move around, they can decide. And we always give them the option to take a degree in computing, which is mix and match. So you can see where we go through up to level 9. And you see the articulation from other programs there. But at level 9, we're seeing most of our students, many of our students coming in now. And we think that's the model that's likely to happen. When you think about it, colleges can cover 7 and 8 to some extent. You can go and do an HND, and then you can come back in at level 9. So it could be school, 5 and 6, college, 7 and 8, and then 9, 10, 11 is university. And that makes a lot of sense for country. And then we articulate right up to MSc and never really give an opportunity to not progress. So in terms of the number of students that we take on in our first year, how many do you think we take? So we're capped in the number of students that we can take on. We'd like to take on more, but we would get fined if we took on. So we all have a responsibility for this. We should be telling our governments and our influencers that we need more places, we need more competing places. How many do you think that we have? That's almost correct. So we have between 150 and 200 start. But as I said, it's our third year that we have a lot of students actually starting. So we see this is not going to be our main entry point for the future. What kids decide we should go out, they're not ready for university yet, and maybe they haven't done as well as they would want to do. Girls and boys mature at different times and so on. So there are options, but we see this isn't our main input anymore. And then in terms of our courses, which one do you think is our most popular there? So this is the end point. So we have a lot of switching. So students will come in on a certain course and will generally switch. Which one of those do you think is our most popular? And that's not right. It's getting there. It's getting there. Games is certainly the thing is that games has mathematics in it. And kids need to understand that they need to be mathematicians. If you don't know linear equations, then you can't do games development. So it's important that they understand that they might like to play games, but when it comes to writing them, I can assure you they need a very strong. So certainly games is one of our most popular. It's number 4, security and digital forensics. That's our largest program. We have a lot of kids moving into it, and so on. And then number 6 looks pretty there, 4%. Networking is one of our most popular courses. Lots of jobs, we have a Cisco Academy and so on. So, unfortunately, business information systems. Why is it? Why? There's lots of jobs out there for business information systems. What is the problem, do you think?
We don't like business.
We don't like business? Yeah, it's very difficult to teach business and IT at the same time. You've got to teach IT and then a bit of business. It's a very difficult balance, but most of them will go into business environment, and you actually find most employers say we want them to do business, we want them to be able to write well, and so on. So it is a very important area. But certainly 4 is the most popular just now. Whether it will change, who knows? But that's the area that's doing. And I gave it away there. And the least popular of all those courses. I was going to put a bet on that one, but so that's good. You're a good class on this. So that is and it's unfortunate because there is lots of jobs. It's very difficult to make it seem interesting. Easy to make that. I do penetration testing is one of the big skills just now. If you want to make money in the industry, you're a penetration tester, which basically is you take an adversarial role against the system. So a bank says, go in and get some passwords and come back and tell us because we don't want some other person to get it. A lot of pen testers in Scotland, because they're working for banks, they're making a lot of money. They have great jobs, they are rock stars. Basically, a games designer is a rock star. So our kids are going into careers that really give them an excellent opportunity to make money, to have an enjoyable environment, and to go anywhere in the world. You go anywhere in the world, and this is a generic industry. So well done, you got that one right. So how much do you think kids, how do do you think kids actually know the opportunities are out there? See, the thing is, you lift the newspaper now, you don't see jobs anymore. Because most of the jobs are recruitment agencies. You don't have to, you go to recruitment agencies, you find a job, and they'll give you 10 jobs next day and so on. So you don't see a lot of the jobs that are actually there anymore. At one time you would see there's lots of jobs in this area. That doesn't happen. So how well do they think they know? Oh, isn't that worrying? I mean, I really desperately worry about that our kids, my sons went into computer. I told them not to, but they went into it after me. So, but you can see here there is an articulation problem that kids need to know, that it's not just playing with games and using iPads and so on. Actually, there is a career out there, well-paid career, and a good, strong career. No one has said very well there, or even good knowledge. We have virtually no knowledge of what's actually out there. So what would you say is the most interesting area of those? For kids. If we went out and lectured for them, it's the most interesting lecture ever, and every single pupil came out of it saying, I really want to know, what would we do? So let's see how 5 gets on this time. I mean, computer networks, we love it, but it's very difficult to make it interesting. It is interesting, kind of, but it's really difficult to set up a switch in the monitor and so on and make that sound interesting. Computer games, so we need to get them in, we need to get them to interested in games, writing software, scripting, it doesn't really matter, thinking about games and so on. So the interactivity is very important for them. And AI is definitely robotics and things like that. Unfortunately, the jobs just aren't there in AI. There is possibilities, but it's software engineers. So it's software engineers that will get a job more than say if you're an AI specialist. And 4 is it's good to see. That's what we've generally engaged kids, because they like things like hacking and so on. What we need to do is to turn them into non-hackers and to be highly ethical. That's a challenge. Okay, and what's your interface with universities? I couldn't believe I looked like together. You picked up very quickly there. So how good do you think we integrate as a community in Scotland? And so you see here, you're saying 3/4 of you are saying that you have virtually no interface to what's going on, and it's our problem. It's not your teacher's problem at all. It's us. We don't have to try too hard. We get who cares? We get students who cares. That doesn't matter. I bet if we struggled to recruit, we would be out in schools knocking on your door all the time, as in give us lots and trying to stimulate the kids. So it's our problem. So we in Edinburgh we run IT for You, which I think is Keith is part of the panel, and we've continued with it. It's a way to get kids to come in and do fun things and so on. See at university, it's not quite as scary, and professors aren't sort of scary either. Well, that's debatable. But it's just a way to make them feel that this isn't a bad place. Actually, it's quite nice. And it's a nice surroundings and so on. So there is that one. So the other 2 universities in Edinburgh moved away from IT for You, but we've continued it because we think it's important. And industry is telling us we need more kids into computing, give us more, and so on. So we'll go on to what we've tried to do to get rid of that. So here we go. What if we were to promise kids something? What is the thing that kids are? I mean, I know kids have got many motivations that maybe aren't future careers. If we were to sit in front of them and say, well, computing has, what would you think are the things that is the thing? So we've found 3 things here. Does anybody want to pitch in here to say what they think is likely to be the top thing here?
Money.
Money, that's one.
Media.
Parents, role models.
Media.
Media.
Knowledge.
Knowledge.
Careers.
Careers. Okay then, so does anybody want to put any money on any of these here? I'll lay down some bets. So you've not said one, and you're being very humble, I think. You've been very humble. You ask anyone about what they liked about the school, it was Mr. So-and-so and Mrs. So-and-so, and I love biology because of that person. So you've been very humble, and I appreciate that. Good teachers. I mean, really, it's basically good teachers that will motivate them. If you have a good computing student, a good computing teacher, they'll love it, and they'll become teachers. So hopefully it's going to appear there, and it didn't. That's how honest you're being. Most of the surveys that we've done up to now, it's good teachers. Good teachers, parents, of course. It's parents. Parents are telling the kids you want to be doing that, and it's obviously family and so on. And then we're kind of bumping around the bottom there. I can't believe you went for good teachers, because really, I asked my graduates about, and they said, yeah, I remember that person, I got into that career because of that person. It's actually the teachers that make the big difference. I love biology, so I don't do biology now, but I had a great teacher. He listened to everything he said. I didn't go into it, which was unfortunate, but that was, my physics teacher wasn't so good, but I ended up going into electronics, so that maybe just doesn't show a great focus there. And media pressure, and peers certainly, good role models. So we've found basically money, teachers and parents. I personally think that's not in that order, but you tell them there's good salaries, that's great. Their parents tell them that there's jobs there and so on, and that's also good. So it's strange that we don't actually agree for these things, but it's important that kids actually realise. So what we did, we decided that we'd have a very small scale event in Edinburgh. We'd call it a cyber lecture, and we'd get Police Scotland to come in, and we'd get some industry people, and to get people to get safe online and so on. So we went out and we got 800, and we had to eventually stop hit. We had 2 lectures of 400, the scariest lecture I've ever given in my whole life. We're doing it again, which is unfortunate. I promised my wife last year that I would never do that again, but we're doing it. The attention span of kids, as you know, is about a minute and a half, most of our boys. You just got to keep, and 400 in a big audience is something else. And I've got the greatest respect for teachers on this. And this is what came back, since it's about time, for goodness sake, what's going on in Scotland. You've actually, so they were saying, and every teacher that we've spoken to is saying, good on you, that's it, that's what you really want. And get industry in there, get the police and so on, and get academia in there, and get the kids. So we looked at, it's good to be, we keep it pretty simple, good and bad, and that's our kind of security model. Unfortunately, many kids want to be Eve. Eve is the evil one, Bob and Alice are the good people here. And Jake went into prison, and he's out and he's on the lecture circuit. You need to read Jake. I mean, really, a great example of he talks about being alienated from society. He's in his little room in the Shetlands and stuff like that. The guy has came out of this, and he talks about how alienating the internet was for him, and now he's a grown-up person. So we've got to try and get people to not think that they're well-set and anonymous and so on. So there's a good message that we've got to try and say that these are going to be the ethical hackers of the future. And so we do security, and the great thing about security is really the science of everything, and that's quite good because you need to understand every little thing about security, and it's a major threat. So we don't have too long, but I'll give you a quick example of some of the things we've been doing as part of IT for You, and also for the cyber lecture. And remember, hopefully I wasn't the only one that actually found it quite interesting to send secret messages to people using Caesar codes and so on. Maybe I was so sad when I was little, but I used to enjoy that, and kids love that. And they don't get a chance to do secret messages and codes. And we were amazed. We could give a code to a child and they would crack it in an instant. And you say, how did you do that? Because our postgraduates will take minutes and so on. And they have a natural talent that we beat out them with a pulp. And we say there's a methodology for doing these things. But kids have that natural talent for cracking codes and so on. So this is an example of one, very good, very easy. Pick a pen, basically it's a little bit. So can anybody read that code there? Without me telling you what the code is? Napier, that's right. Yeah. So they love that, and there's, we give them examples of that. So we've generally tried to motivate them into different codes. When they come in, we give them things like Morse code. And in the Morse code, we can explain that why is an E shorter than a Q, and so on. A very important principle, and they should understand that an E is a more popular letter than a Q, so it has a longer code. Can everybody spot what that T-shirt actually says? It's an acronym for something. It should be black and white. That gives you a clue. I know it's a long time since you did Morse code. NUFC, which is actually the Newcastle United Football Club. Can you imagine a Newcastle United football supporter? They're all in black and white, and this guy goes along and he's, oh, look, I've got Morse code. I don't think it will last. It's very long. And that's actually a Morse code bracelet. Unfortunately, the QR code doesn't work. We tried it from a distance. So we've generally tried to explain basic principles. We all remember Caesar code and stuff like that. We've tried to sort of go through that. And from that, we look at the basic principles of that. And then we look at scrambled code. And they should understand that there's only 25 codes that are possible in Caesar. And they get it straight away. And then you see, well, a code like that, we've got billions and billions and billions of codes. But you can crack it. Any human can crack that code within a few minutes. And it's all to do with the probability of the letters and so on. So there's so many opportunities out there. I mean, for our kids, the key thing is really to articulate the interest, the jobs, really trying to get them to come into this career. And even if they go to college and so on, then they're coming back sometime later. So the opportunities are out there. Does anybody have any burning questions? At all?
One question, one of the questions we asked was, how well do you think that people know what jobs are available in Scotland?
Yeah.
I don't think that's a big problem. I don't know how many politicians, councils, head teachers actually know what's available in Scotland so that we can actually get more computer science teachers into school.
I completely agree. So if I had the choice of voting for a certain party or not, I would make a decision on that. To me, it's a fundamental. This is the biggest change in Scotland. I appreciate we've got a little thing coming up next year, which is one thing, but we'll get over that no matter what happens. But this is our future, and computing is part of everybody's life. At one time, my mum was an iPad man. My mum's the best advocate of iPads ever. She loves it, and it gives her a wind on the world. So the whole days that this was a niche industry is gone. Every industry is now based on it.
I think if you're not in that industry, you understand that industry. You don't understand the kinds of jobs that people are doing as well. And we've got a school out